All right, expected value is part of the lesson on 11.2. And since it's a trickier concept, I'm going to record this separately. So if you need to watch it more than once, you only have to watch this separate part. Expected value it's a Common Core standard. So we're supposed to consider it important. And there will be a question on the quiz at the end of the week about this. All right. My warm-up is back on some of the probability stuff we did yesterday. So I'm going to try to go through these on the calculator with you real quick. Mr. Hanlon distributed a 5-question multiple choice test to his students. There were 5 choices for each question, and Ashley's going to guess on each question. What is the probability that Ashley guesses successfully 3 out of the 5 questions correctly? All right, I'm going to use the little cheat we learned in the last video, which is, it is a binomial question because she's either success or fail at each question. So this is our number of successes we want. And the number of questions is our number of trials. That's supposed to be a T. Now, if there are 5 choices and one of them's right, then there's a 1 in 5 probability of success. There would be a 4 in 5 probability of failure, but remember that little, so if we were doing it by hand, we would do the number of combinations where there's 5 attempts, she wants to get 3 of them right, times the probability of success, 3 times the probability of failure, and she would be missing 2 of them. That's the by hand way, but I'm going to do using that Binom PDF on the calculator. So I go second vars, and that wasn't second vars, there we go. And then I'm going to scroll to A, and there were 5 questions and 5 choices, so this is 1 out of 5, which you can type it that way and then you hit enter, or you can make it a 0.2. It's the same difference. It's going to calculate it the same way. And she wants to get exactly 3 right, so we're going to put a 3 here. And we're going to hit enter, and it's going to go into the home screen that way. I could go back in there and show you that it works if it's a 0.2. It's exactly the same thing. All right. So the chance for this first one, what is the probability she guesses 3 out of the 5 correctly, is a very small probability. It's 0.05, or roughly a 5% chance that she gets 3 out of the 5 right when she's totally guessing. Not a very good idea. All right, what is the probability in part A? So she still gets 3 right, but if the number of choices went down, so the probability of success is now 1 out of 4, and the probability of failure is now 3 out of 4, because there's 4 choices. So if we go back here, we certainly could have gone in and just changed those calculations we just did as well. But from this screen, we're down 5 questions asked still, 3 she wants to get right. That hasn't changed. But this time, it's a 1 in 4 or 0.25 chance that she guesses correctly. So this time it's up a little bit. She has a 0.08, what did that say? 7, so 0.88, almost 9% chance that she manages to guess 3 correctly. Still very bad. Don't guess on the whole quiz. Okay, what would be the probability in part A if the quiz contained only true-false questions? Okay, so she still wants to get 3 right out of 5, but this time it's only true-false. So this time our probability is 1/2 for success and 1/2 for failure. So I'm going to do my little shortcut this time and go second enter. And I'm going to change this to a 1 out of 2 chance that she guesses correctly. Now that's a much greater chance. So there's a 31% chance that she gets 3 out of 5 right. 3 out of 5 would be a 60%, so maybe passing if we were doing percentages. So she may have passed 31% of the time if she was totally guessing on a true-false question. A true-false, got 3 out of 5 right. All right, so that's a review of the binomial probability and using that on your calculator. So the expected value business is the expected value of a random variable is equal to the mean of the random variable. So what is the average result? So at a raffle, 500 tickets are sold for $1 each. There are 3 prizes given away. One of $100, one of $50, and one of $10. What is the expected value of your net gain if you buy a ticket? All right, so your net gain, if you buy a ticket for $1 and you win the $100 prize, okay, that means there's a $99 gain. You gave them $1, they gave you $100. All right, or you could win the $50, which you would gain $49 because you paid $1 for the ticket. You could win the $10 prize. You'd really only gain $9. But a whole bunch of people are going to lose the $1 they originally gave, and that's this -1, okay, because they're not going to win anything. Then you multiply by the probability. Now, we're not going to worry about whether they drew the tickets one after the other. It's just a simple probability. There's one ticket out of 500 that wins $100, 1 out of 500 that wins 50, 1 out of 500 that wins 10, and 497 are losers. So you take each of these probabilities times the gain or loss, not how much the ticket was worth. So $99 gained was that percentage, plus $49 gain was this probability, same probability, because remember all 3 winners had the same probability. And then 497 out of 500 times, everybody's going to lose $1, and that's this one. And you add them all up and you get this. Now, can anyone actually lose 68 cents on this ticket? No. All right, but if you bought all of the tickets and averaged out your loss over each of the tickets, it would be a 68-cent loss per ticket. Now, you have to decide, is it worth it to do that, okay? Sometimes this number will even turn out positive, in which case it's crazy not to just buy all the tickets, I guess. But be real careful. You can't say the average winning will be 68 cents. It's if you were to do it, you can say that, but it's not outright an average. You'd have to buy all the tickets, okay? So don't interpret, say one person is going to lose 68 cents, because you can't actually lose 68 cents. Don't misinterpret. All right. So here's my examples. A water park makes, I'm going to call this their profit, $350,000 if the weather turns out to be normal. And they lose, so this is going to be a negative $80,000 per season when the weather has more bad days than normal. If the probability of having more bad days than normal is 35%, so 35% of the time they lose $80,000. The rest of the time, which would be 100 minus 35%, or 65% of the time, they make a profit of $350,000. So it's the amount of profit times the probability, the amount plus the amount of loss times that probability. And that gave me this number, which means on average, over a period of many, many years, the water park would average a profit of about this much, okay? Now, it doesn't mean necessarily during any one year, but if this held out over a long period of time, they would average a profit of about $200,000. All right, another example. A resort is planning a bicycle race. The cost of sponsoring the race is $8,000. So they are currently in the hole $8,000. The resort expects to make $15,000 on the event. I'm going to call this a profit. It's not really very clear if you have to take that $8,000 out. I'm going to say this is after the $8,000. They clear $15,000. There's a 30% chance of a hurricane, and if that happens, the race will be canceled. So they could make $15,000 as long as the race goes on, which is 70% chance. Or they could lose $8,000 if the race is canceled, which is 30% of the time. It is pouring rain with the sun out at my house right now. I'm sure I'm missing a fabulous rainbow picture. All right, 15,000 times 0.7, was it? Plus a negative 8,000 times 0.3. I hope I remembered those numbers right. Yeah. So their average earnings, averaged out over a course of many years of doing this, would be $8,100 to the good. Okay, so now they have to decide, is it worth it? Okay. The second one is a little more confusing for students because we don't all understand how this works, but it says an insurance company insures a painting worth $20,000 against theft for $300 a year. That means we're paying them $300 to insure it. The company has assessed the probability of the painting being stolen in a given year as 0.002. What is the insurance company's expected profit? So if the insurance company has to issue a check for $20,000 if it's stolen, but we paid them $300, so their net loss would be $19,700, and that's only going to happen 0.002 of the time. The rest of the time, they're going to keep our $300 and run. So if I did 1 minus 0.002, I'd get 0.998. I did that right. And that time they're going to keep all $300. So let's see if I can put this in. So they get $300, 99.8% of the time. But they lose, whoops, I don't want a minus, I want a negative. $19,700 if that painting happens to get stolen, which is 0.002 chance that happens. So on average, they make $260 a year. So their expected annual profit is $260, and that's basically saying it's just an average out over many, many years. This is what actuaries do. They deal in how to come up with this kind of data so that they know, help the insurance company decide what is the chance that this is stolen. So what do we need to charge so that we're going to come out ahead? All right. And raffle, because I think the one on the quiz will probably be a raffle. So here we go. Suppose you hold a raffle fundraiser. Somebody gave us 3 calculators to give away. Okay. We have a $15 calculator, a $45 calculator, and a $100 calculator. One of each will be given away. If we are to sell only 50 tickets for $1 a piece, so we're only going to make $50 on this raffle, it's a bad idea. But find the expected value of a ticket. So what we're saying is the chance that you win a calculator is 1 out of 50 for each calculator. And so 47 out of the 50 people are going to lose their ticket price of $1. So we have 47 out of 50 people. Whoops, I can't write. 47 out of 50 people are going to lose $1. And then 1 out of 50 people is going to gain a $15 calculator, but they still had to pay the dollar ticket price, so they really only gained $14. That's where students get a little foggy. And then 1 out of the 50 is going to get a $45 calculator minus the cost of a ticket, so they will gain $44. And 1 out of the 50 is going to get a $100 ticket, a $100 calculator minus the cost of a ticket, or they will gain $99. All right, I did that on the calculator and I got an average of 220. So it was positive. So an average gain of 220 a ticket. Let me scroll down here. I explained this a little better at the bottom. I wrote this all out to try to make it go faster. So on average, a ticket holder gains 220. Another way of thinking of it is, if you were to win all of the calculators, that would be $160 worth of calculators, okay? For the $50 in tickets that it costs you to buy all the tickets, you would gain $110 in value. Spread out over 50 tickets, that would be $220 a ticket. So it's another way of thinking about it, okay? Now let me put this little box back down here and make it smaller so you can see that in the notes. There we go. All right, so you have a few questions on this on 8.5a, and then you have some on 15a. So this was expected value. Sorry, this video got longer than I wanted it to, but expected value.